making biodiesel. So before we have learned that biodiesel is simply an methyl ester with fatty acid chains. However, esterification reaction is not what we use to make a biodiesel. We use something called transesterification reaction, and that is due to the ingredient triglyceride that we're using to make biodiesel. So we need to first know about glycerol. So what is glycerol? Here are 3 methanol molecules. You know them, okay? So I'm going to first cut out these hydrogens in between them and then link them together. You see here, this molecule with 3 carbons connected to 3 hydroxyl groups. Okay? This is our glycerol molecule. Its systematic name is 1,2,3-propan-triol. It has 3 hydroxyl groups, and each hydroxyl group can react with 1 carboxylic acid and turn into an ester. As we said, it is only the functional groups that we care about. Okay? So 1 glycerol molecule can react with 3 carboxylic acids simultaneously, that is at the same time, and producing the result is a triglyceride molecule. Here, this is the reaction. We have a glycerol, and since we have 3 hydroxyl groups, we need 3 fatty acids, so 3 carboxylic acid, producing 1 glyceride. Okay? And of course, we have 3 water molecules as a byproduct. So a triglyceride is simply an ester-like molecule made by 3 fatty acids and 1 glycerol molecule. It's linked by 3 ester functional groups. Okay? So this entire reaction is a condensation reaction. And if you look at this triglyceride, you can still see this used to be the triglycerol, and it's linked with 3 flags of fatty acids. Now, transesterification. This triglyceride widely exists in nature, normally in plant oils or in pembas, belly fat. Okay, so animals' belly fat, or basically any fat. Okay, so using this triglyceride, we are able to make real esters. That is our biodiesel. Okay, so all we need to do is we want to somehow cut this part off, this glycerol part off, and replace it with 3 methanol. Okay, here, have a look at transesterification. We have a triglyceride molecule, the ingredient of which is, it could be palm oil, it could be any basically cooking oils. Yeah, we have them in those oils, and we add, here is your ester functional group, and we add 3 molecules of methanol in it. And this reaction, if it goes forward, then we can swap out the glycerol molecule and produce 3 fatty acid methyl esters, and that's our biodiesel. Okay, so you can see that fatty acids are still here, and the glycerol part from the triglyceride is now here. And then that's our biodiesel. And this reaction for this reaction to go forward, we need to use a strong base, normally potassium hydroxide or sodium hydroxide as catalyst, which is very, very different from an esterification reaction. Okay. So will the fatty acid chains actually affect biodiesel made? It actually will in terms of melting point. So some fatty acids have carbon-carbon double bond in their chain, and therefore they're called unsaturated fatty acid chains. So biodiesel made with those fatty acids normally have lower melting point, which means they can stay as liquid for larger range of temperatures. And that is basically because of the kink that's caused by the carbon-carbon double bond. And these double bonds prevents these hydrocarbon chains from packed closely together, and therefore these kinks weakens the dispersion forces between different fatty acid chains. So the biodiesel as a result can remain as a liquid for a longer period of time. And we actually want that. So biodiesel made from vegetable oils normally contain more unsaturated fatty acids, and they're actually better performing biodiesels in reality.